Welcome to the Niagara Learning Channel. This site was installed, I think, in 2018. I can check that by going into the platform and looking at the station credentials. But yeah, I think it was 2018, and it's rarely used, this apartment, but when the client does arrive, he wants it nice and cold. I think he's from Dubai or some area like that. And looking at the schematic, we have got two heat pumps here, heat pump 1 and heat pump 2. And as you can see, we are, if heat pump 1, heat pump 2, sorry, is enabled, we've got the brine of 21.4 coming back from this chilled water tank, and we've got 17.1 going into the chilled water tank. And here we have got fan coils attached to this pipework, so this valve is actually closed, so there's no heating to the fan coils, it's just open on the chilled side. The reason these are purple is the mechanical engineer asked for these to be open, just one valve. They fitted two valves per circuit, but they didn't need to, so the mechanical engineer asked for each one of these sets of valves to be open all the time, so hence that's why they're overridden. So we've got CV1 and CV2 open, and we're pulling out. Now these temperature sensors are strap-on temperature sensors, so they're not actually monitoring the water in the copper pipe. They are laid on top of the copper pipe. So there's going to be a slight difference where this sensor here, 18.7, is actually inside the chilled water tank. So I believe there's 18.7. I know it says 21.6 going out and 26.8 coming back. So chilled water, our set point is at 16 degrees. So our PI loop is at 100% because we want 16-degree water or below before this PI loop decides to start falling and switching off the heat pump. The heat pump, like I said, is currently delivering 17 degrees. This is mixing in the tank, the returns mixing in the tank to give us our 19 degrees temperature there. And currently they asked me to disable the bedrooms because he doesn't use the bedrooms, not the guest bedrooms, but the master bedroom is enabled and the reception area is enabled and the lobby is enabled. This is the only areas that's got fan coils. It's for cooling or heating, depending on summer or winter. But even in winter, he prefers the fan coil system to be on in cooling. So he does like his cold, but at the moment, looking at these temperatures, they are still high. And he's coming to site, I think, on Friday, and it's now Wednesday, so it's a few more days to go. Hopefully we can get this down to 20 degrees. The problem we have with this particular system is we wasn't allowed to place any units outside on the roof or on the walls. So the LTHW that we are producing here, the 38.9 degrees coming back 33.9, is going through this CV9 and going to this plate heat exchanger and then coming back. So we're using the plate heat exchanger this side to dissipate the temperature, the LTHW, which is the byproduct of when we're cooling. The LTHW is the byproduct, so we've got to get rid of it somehow. It's pointless getting rid of it into this tank because this tank feeds for the underfloor heating and the manifolds, and we've got that off. There's no underfloor required. We want chilled. And then these two gas boilers up here, they are feeding the domestic hot water system. They can also feed this buffer tank if they choose, but we don't ever feed it. So this valve here is bypassing all the way back, this CV13. So we're never feeding this tank. So what we can only do with this hot water here that this is producing is we're running cold water supply through the one end of the plate heat exchanger, coming in at 23.5, but again that's a strap on, so I would say the cold water will be 16, 17, 18 degrees, and we're heating that cold water and putting it straight down to drain with the CV11, and that's the only way that we can actually get this heat pump to work without putting an outdoor unit, and we wasn't allowed to install outdoor units. So that's giving you a little bit of an example of the system and what we're trying to do with it. I'll just go through some of the graphics for you. Very basic, because this is for engineer use only, really. The client doesn't even look at this. But we have different time clocks, as you can see down at the bottom, and then we've got the fan coils here. So lobby fan coil unit, we click on it, pop-up boxes come over onto this other screen, and we have a control temperature of 25.5, and we're delivering 24 into the room. So we're stripping 1.5 degrees off the temperature currently, and we have the set. We want to try and maintain 20.5 degrees with the set point there, and then we have adjustments that we can use for the fan coil speeds if we choose to. And then this is just an adjustment that says that once the PI loop reaches 10% or above, we start the fan coil. So that's all this is for, the fan speed. We're naturally occupied and we're starting the fan coil. The setback temperature, if the setback time clock is on, which is currently disabled down here, we'll set it back further to 18 degrees at night time. But that is that one, and then it's the same for all the other of the fan coils. Again, this one's just gone across to that side. So that is, the wall temperature is 24.2, and we're supplying only 24 points, so we're not stripping much off there. That control temperature of 27, that's on the room thermostat, which is located normally near a light switch or near a door. So you can't really take that into consideration for a thermistor that's built into the remote control unit for the fan coil. This is a better temperature to take into control, the 24.2, not that 27 degrees. But that's basically the wall controller giving 27 degrees, but the temperature sensor inside the room is giving 24.2. So that's the sensor that we would be using. We've got some switches up here, which we've got the underfloor pumps off at the moment. Let me just show you how this switch works. We click it, it goes to auto. We click it again, it goes to hand. We click it again, it goes to off. Simple as that. And how we do them switches, if I look in switch 1 there, that's a PX file for switch 1. And we have some logic here, the strategy switch, graphic was switch 1, hand auto, off or auto set, and the action arg is set to 3, and that is just for the value binding. So when we actually click on this switch, we get the auto, we get the hand, and we get the off. And the graphics for this, I think, is a standard palette, kit PX HVAC miscellaneous dial switch, middle position for that particular one, but layered on top of each other. If I move this lot around and I edit the properties, and let's put this to a larger size. Let's put that to 500 and that to 500 and move that back. I could take that there and we'll bring in this side piece here, and that is one that's invisible at the moment, and that's the other one that's invisible at the moment. That's the only one that's actually shown. If we click on this one, let's make it visible. So see the visible there. It's visible in hand, but in off and auto it's not visible. But let's just turn that off and unanimate it at the moment, that one. So you can see that one there. And then this one is the other one. Let's unanimate that one. And then you can see the other one there. So there's these three basic switches, three basic graphics that go invisible or are set to be viewing depending on the output. I'm not going to save that, so let's go back, save, no. So now that's back to how it was. And then if I go into the logic for that, which is strategy and switches, graphic switch 1. So this is our normal enum switch. Hand is 1, off is 2, 3 is auto. I've put that into numeric writable. You didn't need to. You could have actually took that out of there and put that directly into here. It would do exactly the same. But I put it into a numeric writable. Let me just do a control key Z, control key Z, so I can actually see what the value is. And then we've got a delay here, only a short delay, 0.5 step, 1 second. And then depending on the value 1, 2 or 3, which this is value 2 at the moment, we get the off. And that will go into here. So this graphic switch there, hand, off and auto. And if it's in hand, it goes through an OR gate and switches the pump on. If it's in auto, it goes into this, which also has an occupied and a frost protection. Again, that is also a switch as well for occupied, hand, off or occupied. So we're in occupied there. So there's the enable. So we've got a true there, we have a true there, and we have a false there on this one here because we're not in auto, and we're actually in the off position, so we're not in hand either. So one that's in auto is there, so that's in auto, which is enabled, and it's also got this from the occupied, and it's also got this from the switch. And that's the same on all the others, basically. Right, let's go through some of the inputs and outputs. Well, first of all, let's just show you the strategy folder. So if I right click my strategy, views, bear in mind this was done in 2018, so I've changed the way I sometimes do some of my strategy now, but it's still working and there doesn't seem to be any issues. It's just taking a while to load up on the strategy here. Come on. There's quite a few folders in this. As you can see, these are all the folders. There's quite a few. And we've got a good connection my side to the site, which is in London, but the site has a mediocre 2018 connection, which isn't fibre optic or anything like that, so it is quite slow. Here we go. So there's our wire sheets. We've got quite a lot of folders, as you can see. Degree days, outside air, time clocks folder, rotation, frost protection, interlocks, all the room temperatures, HVAC recovery, heat recovery unit, booster pump, hall temperature, and then we've got the room controllers. RC is short for room controllers, and then we've got the fan coils, And of course we've got electric tower rails, our main pumps, underfloor heating pumps, fan coil pumps, DHW pumps. And then we've got our heat pump, heating and cooling heat pumps, and DHW heat rejection and boilers. This heat rejection is for that drain, putting the depending on the temperature, we'll put it down to the drain. And then of course we've got all our switches there in the switch folder. So there's a lot going on. So let's go through bit by bit. So inputs, wait for this to load. Here we go. So here's all our inputs. So I have an input folder, and most of my inputs are coming in from mix modules. The mix modules are in Modbus COM1, I believe. Yeah, so we've got 10. Some of these are actually in underfloor manifolds, and I think there's only the first 4 that I believe may be in the panel. And Modbus 2 is our room controllers. We don't have Modbus to heat pump 1 and heat pump 2, so we're just switching it on via digital outputs, and we're monitoring via digital inputs. So they didn't install the Modbus card in these heat pumps, so we're just hardwired to them. So I don't really know what's going on in the heat pumps, but I can see with the temperature difference that they are working. And a normal room controller, if we go to a room controller here, points, fan speed, condition, so they can select whether they want heating or cooling. They can select the fan speed, and they can select the set point. The control variable, actually off that room controller, which we are not using. We're using a temperature sensor that's in the room, the set point, and then we've got the time of day that we send to them with the clock, so that the station's clock we send to them via Modbus, the hour, the day, the minute, so the clocks always give the right time. We've also got some alarms here. If I right click this, views and wire sheet, that should put us into these alarms here. See these network, well, they haven't failed, we just don't have anything on heat pump 1 and heat pump 2, as I previously said. And then of course, if any of these network fails, I will get an alarm. And all we're doing there is taking the current time, and we're using a block that I never ever use anymore, which is, I'm trying to think what make it is now, but it was a block that you could buy, but I separate it differently now. I don't use this block. I don't use any third-party blocks now in many of my logic. I just use a Tridium standard logic. So that's that now. And of course we've got the mix units again with network faults if there's any faults. And these are Modbus. Let's just have a look at one of them. Views, wire sheet. So we've got one digital input to give us all these 12 out. 11's not being used on this one. And then we've got the universal inputs, which have to all be different. And then we've got one proxy point for all these digital outputs. And then of course we've got the individual analogs. If we right click the station, config will do, I think. That's not letting me do anything. That's just frozen on me. Why have you just frozen? Station here. Right click, views, resource manager. You can see that this, I'm using 324 proxy points out of 500. So this Jace 8000 is a 500 point Jace, and I'm only using 324. I'm just looking at the memory usage resetting itself there. The garbage just kicked in and reset itself. Garbage collector. Um, right, where was we? We've done Modbus, we've done them. We were looking at the strategy, weren't we? So there was our inputs. These are our outputs. So this 1, 2, 3 and 4 mixes are actually in the panel. These 5, 6, 7 are manifolds. They're not in the panel. So, but they're networked via Modbus RTU 2-wire, not IP. I explained why some of these were overridden, and everything else seems to look okay. Heating prop into what? Okay, so that one, heating proportional and integral, that's changing the prop and the integral depending on whether set point has been reached or not. The same for cooling on this one. Outside air, so we're taking the outside air temperature and we're adjusting, depending on the outside air, the heating set point and the cooling set point, which, looking at this, is 7 to 18 depending on the outside air. I think the client is just using fixed, and I don't think they are using this. In fact, they are BMS 45, BMS 16, the maximum, yes, and the minimum. So they are using the fixed, they're not using the outside air compensation, i.e. 40 and 16 is our two temperatures. Safety and enables folder, so pressurization and your emergency stops. Simple enough. Safety okay, heating enable, cooling enable. We're not doing any heating though because of the outside air temperature. Degree days, I never ever use this, and I actually don't know why I put it in there, but it was something extra to put in to the logic, seeing you just put in the outside air temperature to it, but I don't bother with that. Time clocks, naturally we do deal with the time clocks. Frost protection, standard frost protection, stage 1, stage 2 and stage 3. That's easy enough to follow. Domestic hot water, it's a long time since I've seen this logic. Safety, Legionella, time clock. So I'm just having a quick look. Each clarifier has a high limit thermostat, yes. Okay, rotation, so I add a rotation folder. I normally build that into my pumps now. I normally don't have a rotation folder, but I've got a rotation folder there. Reset button there. Software reset. So it looks like when we do a rotation, we actually do a software reset as well on a trigger that I'm using, just in case anything's failed. Boilers, the two gas boilers. Again, our safety and boiler 1, boiler 2, so they're both enabled at this stage, and then we've got another boiler check folder which will be for the temperatures, because these boilers won't give a fault, so I would have done it on temperature. So I'll take a snapshot of when it started. Now that's saying that that is in fault. We've got an output there, but this is holding it off because I basically say that if the temperature is less than 60 minus 10, 50, don't put the boilers into an alarm. I think the reason I did this is many years ago, about 3 or 4 or 5 years ago, is because we were getting frequently boiler alarms, yet the boilers were actually working fine. So instead of just stripping it out or whatever, I just added some extra logic. Interlocks, pressurization, fire alarm, just into an AND gate. We've done the switches, room temperatures, so we're just taking the minimum room temperature, which is quite high, but I think it's about 23 degrees outside. And then entrance lobby fan coil unit, and the other fan coil units will be exactly the same. So this is where we can do the heating or cooling of the fan coil unit. We've got a speed select folder there, so we've got a folder. So we've got our loop point now. We're doing minus 100 to plus 100 here. So minus 100 is being for cooling, plus 100 is for the heating. We've got a set point of 20.5. The control variable is 25.5. Hence, that's why we're showing the minus. So we're not in heating mode. We are in cooling mode. True. And require cooling. True. And output set point is 20.5. Right. It will be the same for all these. With fan coils, this won't be the same, because this is for underfloor, I believe. Heating, require cooling. I'm just wondering what that require cooling is in there. I'd have to have a look and see what the ensuite guest 3 is all about. DHW pumps, standard fan coil pumps, underfloor pumps, heat pumps. Lots of folders in here. Heat pump folder there, 1 and 2. This heat pump is enabled currently, but which we saw. The set point 16, control there was 18.7. Valves open depending on whether we're heating or cooling. Electric towel rails. Occupied time clock is on. Towel rails were all controlled to their own thermostat. Heat recovery. Parts per million. Time clock's on. Heat recovery unit is then enabled. Heat rejection, this is the one that we put the water down to the drain. Some calculations there. You can always pause this if you want to have a look at the calculations, but you should be able to see where everything goes to. Apparently I've made a note there, was set at 38. Heat pump cooling, heating cooling required. We've got a booster pump, hall temperature, the hall itself into the building. And I've got a current monitor there, I've got a CT on there, monitoring current. I think that's about it. Let me go back to the main home page. So if outside air is 23.3, if outside air 23.3 is below 10, then fan coils are in heating. That's the only time the fan coils go into heating. There's our current load. We're at 23.4 outside at the moment. and we've got the actuators and the different temperatures here. I normally don't go to this screen. Where I normally go is the schematic. This is the main screen I work from if there's any issues, and this basically will show me what's going on with the system, and we can still see that the heat pump is cooling. We can still see the temperature's quite low in there, but not at set point, and hopefully these temperatures that are enabled will start to fall. I think that's it for this. There's nothing else. There's histories there, so I collect all the histories. I don't put a history apparently on this because it's not. In fact, let's just do that while we're here. Let's take that. Let's do a pop-up. Not that the pop-up will work in this way, but it will work when we log in via a URL. Chart. What have I just done there? That's not my pop-up. Oh yes it is. Let me just cancel out of that. Let me just go back again. Kit. Pop-up. Control key C. I wasn't concentrating, I don't think. Chart. Okay. And that is FCU1. FCU1. Temperature. Lobby. Let's put a mouse over on that one. Mouse over. Highlight. Okay. So that's now highlighted and pop up. But I've got here, which I could try and resolve. Could not load web view. Check that the Fox Web TLS settings match. And we can see the details here. Check that the Fox and TLS settings match. Let's just see what if they do match. So we want Fox. So we want to be in services. So there's our Fox service. We are using TSL version 1.2. Our web service, TSL version 1.2. Now what about our platform? And we want platform administrator. Come on, load up. And TLS settings 1.2. Well, they look okay to me. So I don't see a problem there. Let me just go into my application director. Yeah, we got this is to do with the Modbus 2, the room controllers and the Modbus network. They are coming back okay, but there's a few character issues there. So it does look okay to me, but naturally I'd need to check it on a web browser. Let me go into a web browser. Let me just put you on pause. Well, let's see whether this works. Come on, load up. And we went to schematic, didn't we? And I want to click on that. And there you go, it's going to load. but not giving me any data. Let's just do last 24 hours. Last 7 days. So the last change was yesterday. It hasn't actually recorded another temperature since yesterday. Okay, 6:28. So I presume I set that history to be a 1 degree. Oh yeah, that's a 0.1. 20, oh no, 27, 26, 25. Yeah, I've done it to a 1 degree. So that's the reason why that's not recorded since yesterday, because it hasn't got lower enough at this moment in time. Right, I think that is it. I don't think we need to cover anything else. But you may want to use these switches. They're quite good, really. But unfortunately, you can't just go from off to hand or off to auto. You've got to click it to go to auto, and then click it again to go to hand, and then click it again to go to off. But yeah, they work quite well. All right, thank you for watching.